Hey guys, we are in such an exciting time for astronomy. There's so much awesome things happening. It seems like every day there's something cool in the news, but I want to share with you a little bit about this DART mission that you may have heard about over the past, month or so. This is incredible. So this is from the Planetary Defense Coordination Office, which I don't know if you knew that was a thing, but you could work in planetary defense if you wanted to. What that means is protecting the Earth from asteroids, basically, things that might hit the Earth and destroy our planet. So, important things nonetheless. So, what the DART mission is, DART stands for Double Asteroid Redirection Test. All right. And so, the idea behind this mission was to say, can we, if we found that an asteroid was going to hit the Earth, can we redirect it? And let's test different ways that we might try to do that. And so, this mission was what's called like a kinetic impact test, which is just let's just smash it with something moving incredibly fast and see if we can disrupt its orbit enough to change the direction of this asteroid. So just a couple visuals from this website that's describing the DART mission. You can see how it was intended to work over here. So this is the asteroid system. So a lot of asteroids actually are two asteroids. It's like an asteroid has a moon. And so Didymos is this asteroid that's near the Earth, which is how we could reach it with a rocket. But it has a companion called Dimorphos, and that's what the mission was intending to impact. So the DART spacecraft, which is actually relatively large, let me just see if I can get a picture of it. It's like the size of a person. All right, let's see if we can get a image. Oh, sweet! If you search on DART, you see this on Google, it smashed and disrupted the page. That is sweet. So if I search on it, let's see if we can get a picture of it. And yeah, here's a decent picture. Okay, so there's some people working on it. There's the actual spacecraft. Okay, and but it has two parts. So the actual DART spacecraft, okay, is going to go on and impact Dimorphos, but they want to be able to like capture up close video of this impact. So when it gets close, it releases the Lycia Cube, which is called a CubeSat. So these are like mini spacecraft. I bet we can find a picture of this even too. Lycia CubeSat. And you'll see this is maybe the size of like a briefcase. All right, so here's a person holding it. You can see it's got a camera, okay, because it's going to actually take a video or pictures of the asteroid after this impact. Here's this CubeSat actually attached to the DART spacecraft. So they're going to release this DART spacecraft, smashes into this moon, asteroid moon, and the CubeSat takes pictures of it along the way. Now, what's so incredible about this mission is that they were actually like live streaming pictures from the DART spacecraft as it was heading into Dimorphos, right? So maybe you saw this in the news. This was kind of hitting social media kind of as it happened. These are pictures from the DART spacecraft as it was heading into this moon, which is so cool. You can even see the last picture. It got interrupted as it was streaming back. Right now, this was happening, even though it's sped up. Okay, this was happening over the course of like, a few hours. And I think if you look online, you can actually see like pictures for scale. And like these last rocks are actually much larger than they look. They're not just little pebbles on the ground. Okay, like a person on this scale would be like the tiniest rock on the closest images. All right, so this thing is really quite large. So people could watch these pictures as they were coming, which is super cool. And then what you started to see over the course of the next few days was people sending out pictures because people knew this was going to happen. So people on the ground were observing this event. So here's one of the observations from ATLAS, which is a ground-based telescope. So what you're seeing here, okay, are going to be stars in the background, but the middle thing is the asteroid system. Now they're so close together, it looks like a single asteroid just moving. You can't even see the moon from the ground. But as it's going, you'll see when the impact happens. Whoa-bam! Look at that. That is so cool. We don't see things like this change in space like that fast. All right, it's so cool. Like this was the spacecraft smashing into that asteroid's moon, actually. So cool. All right, so this came shortly thereafter. This was actually an image from the CubeSat, that little CubeSat, the Lycia CubeSat that was released and took a picture the moment the kinetic explosion happened, right? The moment it wasn't like there were explosives on this. This was just like a bullet smashing it. All right, and you can see it produces all this heat and energy, right? And in some ways blew parts of this moon to pieces. You can even see in that moon itself, it looks like it's just like a rocky, it looks kind of loose, you know what I mean? And that's really what our other observations of asteroids tell us. These things are not just like a solid rock, but they're kind of a loose group of rocks held together by gravity. All right. So then the other thing that I'm just starting to see now, right, is there's more pictures coming out. So you want to keep your eye on the news. This is someone actually took a video from their backyard, okay, 2 weeks after the impact. All right, and check this out. And they stacked these pictures. So this is the pictures. All right, this asteroid is going by. Now, again, remember that what we're seeing here is the asteroid and its moon. They look like just like a single picture because it's so far away. All right, and then what we're going to do is they're going to stack those on top of each other so that you can see the faintest amount of a tail. All right, and when they stack them, you can see it way better because you're bringing out the faintest objects by stacking them. All right, and you can see how big that tail is. So it's representing 15 hours of motion in this stack here by stacking them on top of each other. Isn't that amazing? And then I think they're going to stack all the pictures on top of each other here at the end, if I'm not mistaken. Maybe they don't. So you can see there's still material streaming off of this asteroid, and that's part of what's going to continue to disrupt the orbit of this asteroid over time, right? It's not just that one impact, but it also continues to stream off material. Super cool. I just had to share that with you guys. You can actually go to the DART website and you can see the news that's coming out every day. They're verified that the orbit has changed. You can see pictures from the CubeSat that show the impact. It's really awesome. So yeah, I just wanted to share that with you guys. I hope you're doing well. And yeah, keep looking up.